I know it's 12, Ron, but these typically the first couple minutes people are joining, so we'll give it probably till 12:02 and get started.
We start when you say.
I wish folks around my house had that sort of attitude when it came to class. I even mean the littlest of the kids. That's just. Kurt, I see you had your camera on. You've been to a couple of these, I think, haven't you? I think I saw you in the last one.
No, actually, this is the first time I've joined. I've been so busy with title launch that I haven't been able to do anything fun lately.
We have I have recordings we're getting posted of the prior ones. Must be somebody looks just like you.
I get that a lot.
If you want to watch them, so we're gonna send out an email to everyone with the links once we get them all in the same location. All right. I know we ended up with 150 plus signed up, Ron, but you know how these things go, right? Some people are busy, and we'll give it another minute here. One more minute, and we'll get started.
No problem.
All right, we're going to go ahead and get started. So it's my pleasure, as always, when working with Ron, to introduce him. He has been voted the most outstanding professor in our executive MSBIS program on multiple years. So you're in for a treat. He has quite a unique quality and approach to delivering complicated technical material that everyone really appreciates, me included. So when he finishes the presentation, I'll speak a few minutes to our program that we're promoting right now, which is our new online MSBIS. So if you are an analytic-minded person, which I assume you are, and you're looking for an advanced degree, a STEM-certified master's program, we have an option where you can sit at home on Saturday and Sunday and gain that degree, that master's degree, in a year, 2 years, or 3 years, depending on which track you choose. And I'll talk a bit about that. This course that Ron's going to review some content from, some topics that is part of that program. So again, without further ado, let me turn it over to Ron.
Thank you, Tom. I appreciate everybody coming today. Good morning, good afternoon, good evening, whatever is most appropriate for you, wherever in the world you are. As Tom said, my name is Ron Satterfield. I'm a longtime faculty member here at the Muma College of Business at the University of South Florida in Tampa. And I teach a course in our MS in Business Analytics program called Analytical Methods for Business. And I was asked to come today and give you a little bit of a flavor of some of the things that we do in what we refer to as the AMB course, Analytical Methods for Business. Basically, this course has two different missions that it tries to work on simultaneously. One is to teach basic inferential statistics, and the other is to teach basic R programming. And if you're familiar with R, then you know that it is a statistical programming language, much like Python. Most data analysts and data scientists, they're pretty fluent in both R and Python, because there are some things you do where R is a little bit better language for it, and other things where Python is a little bit better. One of the big things this program does is provides a foundation for later courses. Now, a lot of people come into our program and they say, I already know statistics. I know means, I know medians, I know quartiles, things like that. That is what is called descriptive statistics. And it's a relatively small field. Where the serious work comes in statistics and in analytics is what is called inferential statistics. And that's taking a sample of data and then using that small sample of data to try to project what's going on in a much larger population. And there are more complications in that. And that's what we focus on in A&B and in fact in analytics in general. This course is actually a foundation for several later courses that come along in our program. I'm here at A&B and people typically see me relatively early in their course of study. But then we form, I say, a foundation for statistical data mining in particular, which takes the material that I give people and runs with it a little bit further and goes a bit deeper into things. They also draw on the things that I teach in other courses, such as advanced database management, advanced systems analysis design, distributed information systems, and in our big data course, big data for business applications. Now, what am I going to do in this presentation? Well, what I'm going to do here is I'm going to talk to you about a very common statistical analysis tool called regression. Lots of times when you talk to analysts and to data scientists, they will say things like, I have a model, I'm working on a model, my model does this, my model does that, my model I'm trying to improve. What are they referring to? Well, what they're working with when they say model, they're working with a technique that is very much like regression, quite likely. It is either regression or something very, very similar to it. And so what I do in my course is give people a background in that regression. Now, I mentioned to you, one of the goals of the course is to give people a background in R programming. We work with R and R Studio here. R is a free open source programming language specifically for data analytics. Lots of statistical functions, lots of other functions as well. It is free, and so that makes it automatically very popular in the data analytics crowd. It is not the most user-friendly thing that ever came along, so that's why there is R Studio, which is an interface between the user and R and kind of softens some of the rougher edges of R and makes it a bit easier to use. What we're going to do is we're going to take a set of data that I think everybody can relate to, and we're going to explore that data. We're going to use a little bit of regression to build a model, and then we're going to do some work towards improving that model. And a big thing that we work on and that we try to emphasize is interpretation. Anybody can come up with numbers, but where the real value of a data analyst comes in is being able to take the analytics, take the numbers, and explain to people what they actually mean and do that correctly and take it to an appropriate level. Now, as I was mentioning, what is R? It is common software used in data analytics, R and Python. It is open source, meaning it's free. It is collaboratively written by many, many, many people around the world. And there are different parts of R that are written at different times, different places. And anyone can download R. Anybody can gain access to R. We are using it here with R Studio, which is not necessarily open source, but also is a free interface that works with R. And like I say, it's a buffer between the user and R itself, and it makes R a little bit easier to work with. Now, what is regression? Well, you already quite likely know the foundations of regression. I've mentioned, it's one of the most commonly used analytical techniques that's out there. People use it and use it and use it all the time. It is well over 100 years old. It's one of those things where it's a little hard to draw a line and say, yes, this is where it was invented. And it's a collaboration of a lot of people, but folks have been using regression for some time now. What regression tries to do is it tries to look at how variables move together. Now, some people want to say cause and effect, and that's not quite right, because regression as an analytical tool doesn't understand one thing causing another. But what it does understand is two variables that are working together and moving together, and it can tell you some information about that. Usually when I do this presentation for class groups and different audiences, I subtitle the presentation, Everything I Need to Know I Learned in the 7th Grade, because this is based in really fundamental linear algebra. I don't know when your first exposure came to that, but about 7th grade was when I was first made aware of that. And you know how that works. You got an X variable, you got a Y variable, you have a point out there that has an X, Y coordinate. And for regression work, we don't just have one point. We have a lot of points that from those different points, what is sometimes referred to as a data cloud, we try to get an understanding of a relationship, a linear relationship between the x and the y. The x is referred to as the independent variable and the y as the dependent variable. And the way we work with that relationship is we want to know, plot a straight line right up through that data, and the math magic behind regression does that for us. And we want to find out what is the intercept and what is the slope of that line. And those two things together, along with a few other fun things that come along, give us some insight into how x and y will move together. This is what is referred to as a regression model. This is a simple regression model. Why do we call it simple regression? Because it's simpler. It's a little easier to understand. You are probably familiar somewhere along the way in your education with somebody teaching you about y equals a plus bx or y equals mx plus b. This is the same idea because we have a slope here and we have an intercept here. And so basically it says if you know the x, you know the slope, you know the intercept, you can predict what the y value is going to be. And simple regression works on that fundamental basic idea. Of course, takes it a few steps further, but it does work on that basic idea. So it's usually pretty easy to understand. I'm going to take a set of data here that I think everybody has some contact with, everybody can relate to, and that's miles per gallon. Let me come over to a spreadsheet I have running right here. And this is the data that I'm going to work with. And to tell you a little bit about this data, these are 50 automobiles that in one particular year were, this data was published by the U.S. Environmental Protection Agency, which tracks things like miles per gallon of cars. And this is the EPA rating for MPG for the vehicle. This was the horsepower rating of the vehicle's engine. And this is the total weight of the vehicle in pounds. So at the first thing, we have a vehicle rated for 43.1 mpg. It had a very small 48 horsepower engine and weighed slightly less than 1 ton. And we have 50 of these vehicles all together. What we're going to do is we're going to take R and we're going to do some analytics with this and try to uncover how can we use horsepower, how can we use weight to predict what a vehicle's miles per gallon would be and understand the relationship between those two variables, horsepower and weight, and MPG. Now, I have already written a block of code, what is referred to as a script file for R, to do this analytics. So I'm not going to sit here with you and write the code. But what I am going to do is I'm going to come over to R, where I already have the code loaded, and I'm going to execute this analysis, showing you some things that we find out along the way about horsepower, weight, and miles per gallon. Now, I'm going to run this code line by line, reading in my data. There is my data. This is the file, the Excel file where I have the data. Some people prefer to work in text files and CSVs and things. I do things in Excel because my needs in teaching this are just a little bit different. And I'm reading this in with an add-in package called Rio. You can read it in many, many different ways. And when I read this data in, R in its memory has to have a place to put it. And it's got to have a name for that place. So I just told it, call it cars. And so over here in the environment for R, we have cars, 50 observations of 3 variables, and there's what the data looks like. I'm going to do a couple of things to fix up the name and attach it and bring it into R's workplace. First thing, when I get data like this, I like to do some plots. Before I ever do any more serious analytics, I like to do plots so I can get a feel for what's going on. I'm going to do a plot of the weight of the vehicle and the miles per gallon of the vehicle, just those two right there. And there down there in that lower right corner, you see what the plot of weight as the X variable down here, and MPG is the Y, looks like. And there's my 50. Is it a perfect straight line? No, it's not. But we would never expect it to be, not with live data. You're never going to have perfect relationships in those settings. I'm going to do a little plot of horsepower and MPG. There's something there to note. Notice how this looks to be a curve right here. It is not a straight line. Regression, out of the box, basic regression, it looks for straight lines. If something's not a straight line in a relationship between an X and a Y, it gets a little confused. Hello? Gets a little confused. This curve right here is talking to us. It says there's something a little bit different about that horsepower weight relationship. And that's the kind of thing that an analyst would look for, because a lot of analytics work is detective work, looking for clues of different things and seeing where the clues lead you. If I do a plot on the entire data object, I get a matrix right here. This is every variable with every other variable. And I get a sense of how things are related to each other. Well, first thing I'm going to do here is I'm going to do a little bit of a regression on this. This is what is referred to as a simple regression. And what I'm going to do is I'm going to take weight and see if I can find a relationship between weight and MPG, only one of those variables here. And we're going to get a slope and an intercept out of that. I do that with a very simple line of code. You see, there's not too much to this coding thing in it, as long as you understand how they go together and what is referred to as the syntax works. I said, do a little regression for me and put it in something that I want you to call cars out. It will call it anything I want to, almost, pretty close. And then let's see what is in cars out. Well, there, after running line 15, there you see what's in cars out. Now, today we're not going to go into all of that. In the course in A and B, yes, we go into that in some detail, but not today. But the thing we want to notice here is right in this area, the analytics is talking to us. And there's where it's saying, what is the relationship between weight and miles per gallon? I'll pop back over here. This is our regression model. So when you hear an analyst talk about, I got a model and the model's this, the model that, there's your model right there. This is the slope. This is the intercept. The interpretation of the slope is one thing that we would focus on. Here's what this says. Remember, our weight, we said, was in pounds. So we got to remember, what was the actual metric? How was that variable measured, to understand how to interpret that? And what this says is, for every extra pound of weight in the vehicle, we expect a decrease in miles per gallon, because it's negative, of 0.01061 mpg. Now that's a little hard to relate to. So instead of saying for every pound of weight, we might say for every 100 pounds of weight and scale it, and that would be 1.06 that our model is estimating right here. This is a situation where our regression line has a negative slope, which is exactly what you'd expect. The heavier the vehicle, the lower the MPG on the vehicle. So what we want to do with this is we want to sort of experiment with different variables, try different model fits. This is the detective work that we were talking about. I can take a plot of weight and MPG. There we have that plot, and I can put in the straight line that our analysis shows, and there's what the line looks like. So we got a negative slope, we got an intercept up here, and then we have a slope coming down this way. You get an understanding of how the model, this is what the model says is going to happen. Of course, the black dots are reality, and we see reality is not quite following the model, or the model's not quite following reality. That happens. Well, let's take this and let's do a little bit of a change, and let's look at, instead of weight, let's look at horsepower, and we do the same kind of thing where we just say, give me a linear model with miles per gallon is a function of horsepower right here. That's all there is to it. Look at that. And here it's telling us, okay, every extra horsepower in the engine rating, we expect MPG to fall by about 0.236. And we can do a little plot. There's that plot, just like what we saw before, but this is our regression line right here. I told you before, that curve is talking to us. It's talking to us again, because notice regression, we said, only really sees a straight line. So there's the straight line, but there's the data with the curve. Most of our points are above the regression line here, and most are below down here. And that's telling us something. That tells us there's something going on with horsepower that this model is not capturing. So we want to look at expanding the power of that model. Well, how are we going to do that? There's our model as we've got it right there. We're going to go from simple regression to multiple regression. Now, what's the difference between simple and multiple regression? more than one variable over here. So we're going to try to tie miles per gallon to both weight and horsepower. Instead of looking at them in isolation, put them both in there and see what we get in that evaluation. And so I come over here and I'm down at line 31 and I say, give me a linear model with MPG as a function of weight and horsepower together. And then let's look at the result right here. Now we have a combined measure, and this right here is one of the measures that we look at is what we call goodness of fit. How good a fit do we have? And if you've been noticing, that number has kind of gone up a little bit. This is higher now than what we have had before. And we can look at our plot like we said. There is a plot of, this is actual miles per gallon from the data, and this is what the model says. So it's not a straight line right here. We've got 3 dimensions going, so we can't really plot this in a good way here. But what we have is the actual versus the predicted values. And notice that curve. That curve is talking to you again. That's saying something. And that line right there is just a baseline. That's an evaluation, a benchmark line. And if our model had a perfect fit, all those little black dots would line up perfectly on that line, and they don't. Now they're better than they, they're better than they could be. Not as good as we'd like them, but okay, it's all right. It's very all right, but it's all right. Well, what are we going to do about this? We recognize we got a curve in here with horsepower. So what we need to do is we need to do what I call fool regression. Regression out of the box only looks at straight lines. It only looks at straight line relationships. So what we need to do is fool it into considering a curve. How do we get it to consider a curve? Well, the way we do that, we just simply take, someone's not muted, and I'd like to ask them if they could. We just take the variable where we think there is a curve, and we square it. And so now essentially what we're going to have is we're going to have 3 variables in our model: weight, horsepower, horsepower squared. Doing that square will fool regression into considering a curve in the data. So I'm going to come down here and notice what I'm doing. I'm saying linear model, miles per gallon is a function of weight and horsepower. And then here's a little R speak right here that says, hey, I want you to take that horsepower variable and I want you to square it and put it into this variable, into this model as though it's another variable. So I will put that in there, and then let's look at the output. Notice how fast this goes. So this is pretty fast. That's one of the advantages of working with R, is it uses the internal innards of the machine in a more efficient way than other software would. Now, what are we looking at right here? Ooh, that number right there, 000142. You notice when we've looked at all of those values in the models we've done, they've all been below a threshold level. They've all been quite low. That one above it is 1.02 times 10 to the minus 5. You remember scientific notation, I'm sure. We look for anything that's below 0.05. All of those numbers are well below 0.05. So that's telling us, oop, yep, we got something. We definitely found that curve that's in there. We thought we saw it, but now the numbers say, yep, that curve is in there. And we've actually improved the fit of the model. Notice this little goodness of fit measure keeps going up. It says we're getting better and better and better. Now, how do we know how we're doing? Well, I'm going to do a couple of plots here for you side by side. And let me show you what those plots actually are. I'll zoom out on that. This is the original model, weight and horsepower. Notice the curve to the data. Notice how our benchmark line, missing some stuff. This is our model with the squared term right here. Kind of straightened that curve out, didn't it? Now we don't have the curve nearly as strong. That is a good sign. That is exactly what we would like to see in a set of data like this. Because although we don't have it perfect, it's not too bad. It's pretty good. And so we're coming in on being able to understand how weight and horsepower impact miles per gallon. Now, we were looking at our output over here. One of the things that we would need to be able to do is interpret what we have. Well, let me stop off right here just for a little bit. Okay, horsepower was nonlinear. We might look at this and say, how about weight? Well, it didn't show up really strong in the plot, but we can try it here. See if we can get a nonlinearity with weight. The heavier the car, the lower the MPG, but only up to a point. So we will essentially do a model where both variables are squared. And we look over here, weight squared. There's our new term, but it's over 5%, 0.05. So that's telling us no, not seeing it, don't have it. If you want to look at the plot, that's okay. There's the plot. It is not markedly better. So what it comes down to is we cannot find a nonlinear, a curve with weight, but we sure did find a curve with horsepower. So what is all of this telling us? This is the interpretation part. This is what analysts do. Is our model has a good fit. It's a pretty good fit. It's not fantastic, but it's good. Why is that? Well, there's lots of other things than weight and horsepower that impact MPG. Lots of other things do. But we found the big things that do. We found that weight has a straight line relationship with miles per gallon. The heavier the car, the lower the fuel efficiency. No big surprise there, but we have a way of describing that to people. We found out horsepower has a nonlinear relationship. It is a curve. Heavier the car, the lower the MPG, but to borrow a term from economics, it's kind of diminishing marginal return. To borrow a term from physics, it's decreasing at a decreasing rate. So it curves off and flattens out and kind of obviates itself after a little while. We have information here that we can use. Our model is now predicting about a 6.5 drop in MPG for every 1,000 pounds of weight. 1,000 pounds is a lot for a car. And so we have an understanding here of what is the deterioration in MPG for weight. Talking about horsepower to people is a little harder because all we can really say is it's nonlinear. It follows a curve. And so we can't get that clear number to tell the world about in terms of the deterioration because it depends on how heavy a car you're already talking about. Now, let's look at something else in this. If you know your Mustangs, you know that one. That actually is a very
Professor,
famous Mustang. Yes,
can
ma'am.
I ask a question?
Certainly, ma'am. What's up?
Okay, so how do we know that what we have to use to improve the value of R square, or how do we have how can we improve the performance of the model? Like here you
Well,
use the squared value of horsepower and the weight. So how do we actually know it?
I knew I needed to use a squared term because when I did those plots, I saw that curve in the data. And like I say, a lot of analytics is detective work, looking for clues of things that you know or that you picked up by experience, and then knowing to try different things to see, okay, is this really what's going on? Can I say objectively with numbers that's really happening? But it mostly comes with experience and education, working with the modeling procedure and working with different kinds of data. Does that work?
Yeah, thank you.
Sure. Well, where I was, as I was mentioning to you, I said, you know, if you know your Mustangs, you know this one. It doesn't look that great. That actually sold the highest auction price for a Mustang ever paid, and it sold a couple of years ago. And it was $3.8 million out the door as it stands right there. No one has ever restored it. No one will ever restore it. That is a very famous car. That's the Bullitt Mustang, made famous in a movie in the 1960s by the actor Steve McQueen. He wanted to buy it for a number of years, and the owner wouldn't sell it to him. Now, what we look at when we look at models is we look at this thing called errors or residuals, which is how wrong the model is. You know, our model's following a line. And if our point is here, that's actual. This is what the model says should happen. That difference between the two, that's kind of important. We'd obviously like that to be really low, but that is what is called an error or called a residual. And when we use regression, we get really bent out of shape about residuals. We do lots of stuff with looking at residuals because residuals tell you many things. Also, to understand whether a model is useful, we look at residuals to see if they actually conform to some assumptions about regression. There's our model with horsepower squared. Let's do a couple of things with it. I'm going to do some plots with this, and you can see here. I have several different plots, and an R, one thing about R is it lets you customize things in pretty much any way that you want them. And so you see here for my model, here is actual, here is what they call the fitted value, what the model says it should be. If it was perfect, all the dots would be on that line. Not quite there, but it doesn't look too bad. One of the things we worry about is, are those residuals normally distributed, or do they follow some other kind of crazy distribution? We want them to be normally distributed. This plot says they're normal right here. This histogram says they're normal right here. The black line right there would be the perfect normal curve. Now, looking down here, these are the errors or the residuals. And if you look at that, you still see a little bit of an upswing in this. You know, you have to stand back and think about it a little bit, but you see a little bit of a curve in that. Yeah, we squared horsepower, and so we got rid of the big curve. But again, detective work, looking at what is this thing telling us. And the detective work here says there's something else that is impacting MPG and impacting it in a curved fashion, a nonlinear fashion. And we don't know what that is because our data only has weight and horsepower. But if we were really serious about trying to model this and going into it in greater detail, we go look for more variables. And we'd start to bring more things in here to try to explain more of what impacts miles per gallon. So there again is the detective work saying, kind of looks like there's something else in this. And if we really wanted to get a better model fit, we're going to go find some more data out there on these automobiles. We would also do some work like this, and I won't go necessarily into those, but basically those are also telling us, is this following a bell-shaped curve or a normal distribution? And it basically says it's fairly close, which is good. That's what we want. That is absolutely what we want, but we do have a little bit of a curve in this thing. Let me put a lid on this presentation and tell you a little bit about what did we do. Well, what we've done here is we have introduced you or reintroduced you to, if you've seen them before, regression and to R. We've used R with RStudio, and what we've shown you is a little bit of what is called statistical programming, and analysts do this to a fair degree. Statistical programming is getting in and writing a block of code called a script to help you analyze data and understand what's going on in the data. We took some simple data on 50 cars and we did some analytics with it. It's an interesting data set because it's got a straight line in it, it's got a curve in it. We experimented with different model relationships, and that's the best term that I can think of to apply to it, is experimentation, because really that's what you're doing. You're trying different things based off of your experience and your background and you knowing what to do. We interpreted
Ron, we
those.
lost your.
Okay, you lost me? I don't know. Can you see me?
Can everyone hear okay? Can everyone hear okay?
Yeah, we can.
Okay, great. Thank you very much. Okay. What we were looking at here is we were saying we were interpreting the slope and the intercept, especially the slopes. The slopes tell the story on what's going on in the data. And then we evaluated the fit of the models and a few other things with it. Now, this is, you know, this is basic regression. There are many other types of regression that are out there that we teach you in our program. Some of it I teach you, some of it other faculty teach you in more advanced courses. But modeling is an important tool that analysts will use, and we try to give you a very good background in the modeling. That pretty well takes care of it for my presentation. Tom, are there other things that you'd like to tell them about with our program?
Yeah, we could take some questions first if anybody has any questions about the content covered in Dr. Satterfield's course or any of the other courses.
Yeah, I can tell you a bit more about other tools that we cover in the course as well.
And again, this is, you know, just as a sort of to whet your appetite a bit. And if you are interested in, you know, an advanced degree in data analytics, I think I mentioned at the start of the call, you know, we're short 150,000 plus jobs in the U.S. with people with for people with these skills. I'm sure if you just search Indeed or LinkedIn and put in data analytics, you're going to see the opportunities that are available. Can you hear me, Ron?
Yep, sure can.
Oh, okay. If you can see my screen, this program that we have, the new online program, you can complete it in 12, 24, 36 months. It's STEM designated, which is important to a lot of people looking for those technical credentials. You're going to come out with data analytics, technology management. Our goal is when through this program that you end up leading technology investment or data analytics investments at companies. So you're not going to be a Python developer. You'll have computer science master's students who are training to become Python developers for a profession. However, you will do Python development, and you have to have some skill and some competency with technologies to be able to leverage them when you're solutioning, when you're architecting solutions for companies. And that's the goal with our program, is to produce people that are assets that can architect data analytics solutions for companies. Classes Saturday and Sunday for 3 hours, for 3 weeks, and then 2 weeks of project work. Everything is live, which is different. A difference between our program and others is all the lectures are live, all recorded. So if you miss any, you can watch them later if you were confused. It's cohort based. These are the courses that comprise our program. And we've chosen these in collaboration with our industry advisory board, who has said, look, I know some of these are challenging, but we need people with big data skills, with data science programming, statistical data mining. So these are, a lot of thought went into which electives to include. That's how we arrived at this list. And 33 credits, that's what a typical schedule would be if you did it in 1 year. Obviously, 2 years, you're going to take, 1 or 2 classes each semester, and 3 years, you would just take 1 class each semester. And the cost, you're not going to find a better price program anywhere. UCF, Georgia Tech, for what you're getting with our program, and everything's included in the cost. So you get all your online research, all the software. There aren't any books to purchase, so it's just every semester $525 times the number of credits that you take. Also have networking events. We have an alumni network now on LinkedIn, and we're having alumni events, several of them next year. Well, you'll be invited to those as well if you're in the Tampa region. But it's open. This program's open to anyone in the world. So that's all I had, Ron, as far as sort of sharing with people the offering that we have.
Absolutely. And one thing I would mention here is ours is not one of those fully online, sit down and watch a bunch of videos kinds of programs. The kinds of lectures that you're getting from our faculty are exactly what I have delivered to you today, where there is interaction, we are live, we take Q&A, those kinds of things. Yes.
And you're in with working professionals, right? So Ron will tell you, we're challenged sometimes with the sort of the advanced understanding of some of these skills. A lot of people are already in analytics, and they want the credentials and they want the broader technology understanding. They may work with Python, be developers already, and they didn't understand databases. They need to understand, some more advanced programming and R and other technologies that we have. They may need big data. And how do they leverage big data solutions? So that rich cohort environment is a lot of value.
Absolutely.
Any questions about what Dr. Satterfield covered, or any questions about the program anybody has?
I do have a question.
Certainly.
Yes, so my question is for the program, and if the courses are already predetermined, the order that you take them, or the students choose the order?
No, for the program so if you can see my screen, the program, this is the structure of the program. The only thing that will change is if you take a 2-year option, right? You only have 1 or 2 courses in the first semester, 1 or 2 in the second, and so we'll give you the track that you're on, because you will be with the same students, right? This is just like an executive MBA type program. You're with a cohort, and a lot of the value in receiving these types of degrees comes with, you working with those professionals throughout the course of your time in the program. So.
Thank you, appreciate it. So technically, it usually starts in the spring.
Yes, so we have a weekend program that's live in person, and that's downtown Tampa. That starts in the fall, and we have admitted some for the spring as well. So, and then this is the new online version of that program, right? It's the same MS degree that you would get if you came to campus during the day and took classes all day for a year or two. It's the same MS BIS. It's just the mode of delivery is different, and everyone in our programs are working professionals. I mean, that's required that people are bringing business experience to the classroom. But yeah, so and I'll work with in December when I finalize the list of admitted students. I'll work through with each person which track they want to be on. If it's the 1 year, it's straightforward. If it's the 2 or 3, we'll work on the schedule.
Wonderful. Thank you so much.
My pleasure. Any other questions? Well, you have my contact information here. I can always put you in touch with Dr. Satterfield if anything comes to mind that you want to talk to him. The nature of our work is such that working with working professionals, we spend a lot of time talking about industry, challenges, opportunities there are. So we have a pretty good, our faculty are very close to and tied to all the industries and businesses in the Tampa region, which is another benefit if you're in the Tampa region, just because our Rolodex has become part of your Rolodex, and that's a pretty powerful thing to be able to leverage for a student. So Anna, anything else? We want to give away any prizes? We promised that?
I didn't, but maybe that's your department.
Anna might have dropped off. She had a list. Here's
Anna
what we're going to do. What's that?
Anna has dropped off.
Yep, and I'm going to follow up with her, and we'll get some shirts out and some nice things to some of you. We'll have I'll have Anna do her numbers thing that she does, generates random numbers for each of you, and some people will get some nice surprises, an email or call from us to get your address and ship some things to you.
Great.
All right. Well, again, if you have any questions, don't hesitate to reach out. And I think that's all we have for today. Huh?
All right. Thank you to everybody.
Recording. So this is recorded. The previous
Thank you.
lectures are also recorded. So you can watch those if you just need to email me to get the link. All right.
Hi, I have a question.
Yeah, sure.
Yeah, I have a question regarding the program.
Mm-hmm.
Okay.
So what is the difference between this online global program and the regular BAIS program that you have at the campus?
Well, the regular program is predominantly 90+% are students who come here from India who want to take advantage of OPT, where they can work in the United States for 2 to 3 years, and they attend full time. They're not allowed to work here. That's and then they register, they compete for which class they get in, and it's just like when you were an undergrad, right? You go and get in line, and you're online, and you try and get in the classes you want, and you structure things yourself. And predominantly courses are during the day. The weekend and the online are purely for working professionals. The weekend was for working professionals in the Tampa region, or those that can get here 2 Saturdays a month because it's live in person, all day Saturday. The online is targeted anyone in the world that still wants the same degree, but that would like to be at home taking classes Saturday and Sunday for a few hours.
Okay, so anyone who's not working, can they also take this program, online program?
They can. We just, like I said, this bringing professional experience, like if you've ever had a job, is important. Just because what you can contribute to the cohort.
Okay, sure. Thanks a lot.
Sure. But any business experience, any type of professional experience is fine. All right. Any other questions? We're going to add, in addition to these recordings being available, we're also going to add a couple more talks. I think we're going to have one on blockchain next month, and another one on, I want to say, data science program. I'm not sure what Anol is going to do, but
I'm not exactly
build on
sure.
what you covered.
Absolutely. He teaches the major follow-on course to what I teach. He takes what I give people and he builds up on that. And his is in a statistical data mining course.
Statistical data mining. All right, everyone. Well, thanks for attending.
Yes, thank you very much for coming. We appreciate it.
Thank you.
Thank you.
Thank you.
Very
This was a
welcome.
great session.
Thank you.
Thank you. Thank you for coming.